Welcome. Last class we considered I sections. If you remember, random I sections, which actually will not appear in structural engineering calculation. That was only for understanding. Now, most popular I sections. See, one, completely symmetrical I section. One is called symmetrical I section. Symmetrical I section means what? There is symmetry about two axes, perfect, right here, perfectly symmetry, or you can write symmetrical I section as shown. I will explain here. As shown. See, all the I sections in the steel structures you are getting, like ISMB, ISLB, ISHB, they are all symmetrical I sections. So, see here, BF means breadth of flange. You write, this is actually not required information. BF, breadth of flange. Both are equal. See, whatever this breadth is equal to this breadth. TF, thickness of flange. TW, thickness of web. And remember now, this projection equal to this projection. How much is this projection equal to this projection? And what is this width equal to this width? What is this thickness equal to this thickness? So, there are two axes of symmetry. How is it? One this way, one this way. See, AOS, don't write AOS, right? Axis, plural, axis of symmetry. So, G directly located, that is midway between width and depth. Width-wise midway, depth-wise midway. So, I wrote here, centroid G is directly located without any calculation. Because there are two axes of symmetry, G will be at intersection of the two axes of symmetry as shown. I will show the sketch. No calculation of X bar, Y bar. Now, one problem, actually first of all, it is not a problem. See here, while writing, slide, shifting will be there. All dimensions in millimeter. 200, 200, 15, 15. Thickness 12, this depth is 300. No data given regarding the projection. So understood, projections are equal. Therefore, I will write now complete centroid details here without any calculation. See, this is actually not a problem because only information I am telling. But later, moment of inertia is important. Little big sketch I will write here. See, for this one, very centroid. See here. See, 200, 15, 300. This also is, this is how much? 12, okay. This is 12. Same equal, this projection equal to this projection. I think, okay. Anyway, don't worry about too much about those things. You write correctly. Here board, what happens is difficult to maintain exact straight line all. For that you require electronic board. Okay. How much thickness there? Same thickness here. Okay, I see. Refer to this diagram. Okay, everything looks okay, I think now. Okay. Refer to this diagram. See now, first right. For this question, see, this is axis of symmetry. One of the axis of symmetry. Usually we call this as YY later, remember. Okay, I'll write YY if you want. Okay, YY. One more axis of symmetry is here. I will call XX. The intersection point is centroid G. Over. Now, see here. Full width 200. So, if you want this distance, location, if you want this distance or this distance, that is here also same thing here, whatever there, same here also. Since this full is 200, it is 200 by 2 equal to 100, all dimensions millimeter, all in millimeter, and this also 200 by 2 equal to 100. Then, suppose you want, see, this distance, see, this distance or this distance. thickness is 12. So both are 12 by 2. If you require 12 by 2 equal to 6, equal to 6. Depth wise, see, they are not given a full depth. Better mark the full depth ones. The full depth will be, you have to calculate now, because 300 plus 15 plus 15, 330. Show the calculation, rounded. Then, if you want this distance, 330 by 2, that is 165. This also is 330 by 2 equal to 165. Suppose you want this depth for some reason, and see xx, and this distance if you want. That is 300 here, 300 by 2 equal to 150. This also 300 by 2, that is 150. Over. This is symmetrical I section, no calculation, directly intersection of this one. Then, so question number 15 is only for explaining purpose. But remember, later for moment of inertia, calculations are there. When you go for moment of inertia, very powerful question. Usually what I do is, when I take classes for any course, I will take a symmetrical I section, 1 or 2 questions, I will fully explain. Then I will announce in the class. In future, till the end of the course, wherever symmetrical I section comes, I will not explain moment of inertia. You should calculate correctly. Indeed, majority of people, those who are serious, when I put a question like this, they will suddenly tell moment of inertia, sir, 2455.818 10 to the power 6. Yes, good. I will tell that way. Only few people who are not studied properly, they will start wondering how to find. Let them struggle. I will tell, let them struggle. If you are not following what I told, what I can do, following means what? No, people will follow what I tell, not that way. If you are not going through what I can do, if you attend the class, you will understand. There is everything in my class is that way only. Attend the class, go through thoroughly, understand. But if you do not go through fully, half see the class, little, you suddenly this question, see, no problem, I know it. Later, for some reason, I'll put 150 here. Sir, how you got it? Just like that. Okay, this is symmetrical I section over. Now I'll go to other one. People call, technically called asymmetric, but I call unsymmetrical. I like that word unsymmetrical. See, necessary, unnecessary. Able, unable. So I feel, see, it hardly matters. I will explain. Okay. Now come to unsymmetrical I section with one axis of symmetry. See, last class, randomly we considered. It was completely unsymmetrical with respect to both axes. But here, unsymmetrical I section with one axis of symmetry. This is very, very popular. Usually, academic questions solved, they give this way because, what is this one? This way they give because they want people to at least solve something. If symmetric is given, no centroid location. Moment of inertia, there is a shortcut is there. For symmetrical I section, when you go to moment of inertia, just one line answer, shortcut is there. But unsymmetrical, or actually somebody will tell asymmetric, in your choice. Either unsymmetrical or asymmetrical I section, centroid you have to locate. But, and one more thing, moment of inertia, little work is there. You have to apply parallax theorem. Therefore, second one, unsymmetrical or asymmetrical I section with one axis of symmetry. I'll put red color. Right here, rightly. One axis of symmetry. Use red color for. I'll use one axis of symmetry. This AOS. In future, I am putting AOS. When I put AOS, single means axis of symmetry. Two are there means axis of symmetry. Okay. See here. Breadth of flange. This is top flange, bottom flange. This width BF1. This is BF2. They are not equal. One more thing. Do not by heart BF2 more than BF1 like that. Anyone can be more. Then TF1, thickness of the top flange, TF1, TF2, they are different. TW, okay, but one important, this offset should be equal to this offset. Same way, this offset should be equal, see, these two offsets are equal, these two offsets are equal. If that is not equal, it will become completely unsymmetrical, like last time class. No, this will not be, see, how much is this offset? Same offset here. When the question is given, in case data is not given, it is understood that these two offsets are equal, these two are equal. But this is not equal to this one. Okay. But come here. Centroid G, first of all, put the section here. Now, there is, see, one axis of symmetry. How? See, this is axis of symmetry. See, this way, exactly this way. But this way, no symmetry. See, different. This way, symmetry is there. This way, no symmetry. Centroid G lies in this axis. Okay. But where? Question mark. Okay, it lies here. Last time symmetrical section, there was one more axis of symmetry. So intersection will give centroid. But now only one axis of symmetry. So centroid lies in that axis. But where? For which we need y bar. See, if you want to locate centroid of the axis this way, see, this way distance not required. See, this way and this way, half, actually out of scale, both are equal. Little, when I wrote here, little tilted, okay. Half, see, BF1 by 2, BF1 by 2, BF2 by 2, BF2 by 2, okay. If you want these two, see, TW by 2, this also TW by 2. But this way where? So you require vertical distance, we don't know. That is, we need, for which we need y bar. See, for y bar, you have two options. I'll write here. Option 1, your choice, or option 2. Remember, option 1, this time you don't have to waste time. Consider reference axis OX and OY not required, just one edge required. Through bottom edge, see, reference axis. See, one reference axis or reference line. You can take reference axis or even reference line. Or simply you will call later y bar from bottom edge. Y bar from bottom edge. Here we will call y bar from top edge. So, one option, take reference axis here. Take y this way. Then, if you take y this way, then your y bar will come this way. Or, second option, option 2. Okay. Option 2. Take reference axis to top edge. Then consider y this way, then this way you get y bar. Okay, now we will go for examples for unsymmetrical I sections. I will prepare the question. 2 questions I will solve. Question 16. See, when I write in the board, sometime line will become slightly like this. You draw neatly using scale. Should not make issue of that one. See, after taking, today is Sunday, I took a marathon class from 5 o'clock up to 9:30, non-stop class, live class was there. And now it is around 1 o'clock. So, when I feel tired, sometime I need not bother about this, see, slight turning here. You never bother. You understand everything. You draw neatly. You take a scale and write. Question 16. Locate centroid. All dimensions in millimeter. 250, 20, 150, 16, 12. Remember, total depth given 600. Okay. Note, X, first write. This is axis of symmetry. So, if this is axis of symmetry, 250 by 2, 250 by 2. Here, 150 by 2, 150 by 2. Therefore, no need of calculating x bar. But y bar is required. So, divide into 3 parts. Any 1, 2, 3. See. Now, when you divide into 3 parts, 150 by 16. 250 by 20. For this one, from 600, subtract 20. subtract 16, you will get 564. You have to calculate it. Okay, now, part 1, part 2, part 3. We will take reference axis AB, bottom edge. See, we will take bottom edge reference so that why? Now OX, OY all not required. For cement I section solve, don't waste time writing OX, OY all. Okay, start. Then to reference axis to get Y bar this way. So Y this way and Y bar will be like this. Okay, now write statement. Y bar from AB equal to A1 Y1, A2 Y2, A3 Y3 divided by total area A1 plus A2 plus A3. You write A1, A2, A3. I need not waste time on all these things now. If anyone tells, sir, you are not explained what is A1, Y1, A2, Y2, A3, Y3, I will tell, stop attending my classes. You study independently. Okay. You are a genius. You want every class I have to write area of a rectangle equal to width into that thickness, etc. Don't expect all those things from me. Those who are serious will understand. Start now. This time, such a questions, table is not required. Don't waste time. Figure number A, X1, X2 not required. Directly calculate. Why? See, later, this will time consuming, preparing table, then writing all values, all not required. That you require. Later you require, once again. So for such questions, for I sections, see, for this type of I sections or for channel sections or T sections all, table not required. Start. A1, 115 to 16 into its centroid from AB, 16 by 2 plus A2, 12 into 564 into its centroid from here, 16 plus half of 564. A3, 250 by 20 into its centroid from here is 16 plus 564 plus half of 20. You can write, or you can directly write 600 minus 20 by 2. That also will do. 600 minus 20 by 2 directly. Divide by A1 plus A2 plus A3. Y bar will come 351.924. Now, therefore, centroid G will be as shown in figure below. All dimension millimeter. Now, one important. You have to properly sketch the centroid. Otherwise, you will have difficulty for moment of inertia. If you randomly sketch without scale, see here, correctly. This is 16. From here to here is 564 by 2. So from bottom edge to center of the web is 16. You should write all those things somewhere outside. 16 plus 564 by 2. 16 plus 564 divided by 2 is 298. Correct? 16 plus 564 divided by 2. No. Yes, 298. But Y bar we got 351. So surely the centroid will lie above, much above. See, somewhere here. Okay, therefore here. See, center of web is here. You mark above your Y bar. How much you got? 351.924. Okay, over. This is already I told you. Suppose right here. Suppose you want from top for some reason. If it is a bending stress chapter, this will be called Y1, Y2. M by I equal to sigma by Y. There Y is extreme fiber distances. Then once you get how much? Y bar 351.924. Somewhere outside you mark the total depth. Make a practice to mark the total depth so that it will be clear. 600. From 600 subtract 351.924, get 248.076. Rounded means calculated. Okay, over. We got Y bar. Centroid is here. Now, do one thing. Divide into 3 parts. 3 parts. Then I will write alternate solution. Alternate solution. Consider reference axis. Consider top edge as reference axis. Top edge, say CD, some name. See, this I called AB, say CD as reference axis. See, here, you take top edge as reference. CD, some name, CD. Then this will go, AB will vanish. But 1, 2, 3 will remain same. Start. Then y bar from CD, top edge. This time your y bar will be down. See, this time your y bar will be down. Why? Because see, you take y this way. See, take y this way. When you take y this way, y bar is from top you will get. Start once again. A1, 150 into 16. This I have to cancel now. Once again I have to write now because, okay. A1, from here only, A1. Anyone you can take 1, 2, 3. 150 by 16 into, see, its centroid from top edge. 20 plus 564 plus 16 by 2. 20 plus 564 plus 16 by 2. Or you can write, or you can tell 600, see, total 600. 600 minus 16 by 2. Or this one you can write 600 minus 16 by 2. Both are same. A2, 12 into 564. 564 into its centroid from top edge. 20 plus 564 by 2. If this is not clear, I cannot tell anything. Plus A3, 250 by 20. 250 by 20 is the last area into its centroid from top edge is directly 20 by 2. Divide by A1 plus A2 plus A3, your y bar will come 248.076. It will come 248.076 millimeter. Correctly mark here. From here, 248.076. See here, correctly. This is 20. Up to center is 20. Center of the web is 20 plus half of 564. 20 plus half of 564 is 20 plus 564 divided by 2 is 302. 302 up to here from top edge. But we got how much? 248 means from center slightly above. Okay. Now this is your y bar. This is your y bar equal to how much you got? 248.076. 248.076. Then if you want this distance from 600, subtract it, get 351.924. This is centroid G. Any problem is there? Rubbing forgotten? No. I don't think rubbing is forgotten. No, leave it. Okay. Now, last question. See here, your centroid came slightly above the center of web. Next question, I will push it below center of web. It is very important for moment of inertia. When you mark this axis, upper flange, lower flange, no problem. For web, correctly you have to mark. If you mark wrong marking, when you find moment of inertia, you will have difficulty, you will get confusion. How to get the distance here? That way. Okay. I will go for next question, last question today. Not 7.6 actually. See, just now, when I marked this value, camera slightly moved there. So it was not visible. Okay, now I turned the camera and now it is fully visible. Okay, now I will start second one. That's why, see, it was partially cut in the camera. So now I shifted the camera so that this value is clearly visible. That is question number 16. Now, question number 17. Question number 17, nothing to explain much. Fast I will do it. Locate centroid. 100 by 12, see this is 12. 125 by 18, see this time they told this is 400, be careful. Last time they told full depth. So subtracting these two, you got this distance. But this time they told this is 400. So this time you have to 400, you have to add these two and get this one. That much mathematics should be known to you. Okay. Note, x bar not see, axis of symmetry. Therefore, midpoint 100 by 2, 100 by 2, bottom 125 by 2, 125 by 2. See later, 62.5, 62.5, 50, 50. X bar is not required. Y bar, divide into three parts. 1, 2, 3. Consider the bottom edge as reference to get y bar. So, your y will be like this. Okay, this is your y. Start. Y bar from AB equal to A1, Y1, A2, Y2, A3, Y3, etc. Start. A1. 125 into 18 into 18 by 2. I wrote big because next round I want more space. You write small. 18 by 2 plus 10 into 400 into 18 plus half of 400. 100 into 12 into 18 plus 400 plus 12 by 2. Or you can do one thing, 430 minus 12 by 2 also will do. Divide by A1 plus A2 plus A3, y bar will come 188.060. Third decimal. 0 I wrote through that, third decimal. Okay. So y bar 188.060. But be careful. See, last time your y bar came, the distance came above this G2. Now, this is 18. This is 400, this is 200. From here to the center is 218, but you got 188. So it is little downside compared to, see, if the center of web is here, it is little down. How much? 188.060. This intersection is centroid. I forgot to write, actually, I understood. This is your G. Okay, if I write that way, it will spoil the sketch actually. Okay, okay. I'll put here, understood, this intersection is G. Or if you want from top, from 430, subtract 188.06, you will get this distance. Okay, over. Now immediately write. Immediately. After dividing into three parts, you write here. Alternate solution. Next time I won't give alternate solution. Consider top edge as reference. Say, not AB, say CD. CD. To get y bar. See, take here. Last time, remember, I wrote CD here. Now y is like this. If I forgot to remove this one, you make correction there. Okay, y this way. Now your y bar will be from CD. CD, how it will be? Downside. Start. A1, 125 into 18 into its centroid from the top edge. 12 plus 400 plus 18 by 2. Or you can directly do it, or see, or from 430 subtract 12 by 2. No, from 430 subtract 18 by 2. Both are okay. 430 minus 18 by 2 also will do. A2, 10 into 400 into its centroid from top edge. How much? 12 plus half of 400. A3, where is A3? Here. 100 into 12. 100 into 12. Oh, yeah, I not change. I have to change the values here. See. I forgot to change it as I am explaining. Sorry. Second one. 10 into 400 into its centroid from top edge. 12 plus half of 400. I forgot to change the values. 400 by 2. Plus last one. Which one? 100 into 12. into its centroid from top edge is directly 12 by 2 over. Know this one. 12 by 2 divided by A1 plus A2 plus A3. Correct answer? See, 4th, 12 plus 400 plus 18 by 2, 12 plus 400 by 2, 12 by 2. Okay, over. We got, your y bar will come 241.940. It will come, I know it. 241.940 millimeter. Okay, start. Now, from the top y bar, how much you got? See, this is your y bar. Now, this is your y bar. Y bar equal to 241.940. 241.940. Now, you should be careful now. See, 12 plus half of 400. 212, but y bar came 241. So if you do from top, it will cross the midpoint of web, further come down. Okay, now those who want this distance, you calculate. How? From 430, subtract that distance, get this one. See, I forgot. Sometimes people are there who will comment. Hey, he told in the question, he told CD, and then he is AB he has not removed. Okay, what to do, Hutch people, we cannot do anything. Okay, now this will finish centroid for I section. Next class, I'll go for channel sections. After channel section, some box sections are there. Then after that one, from trapezium already over earlier, I had to go for all composite type, mix up. That is one by one in order. Question number 17 over. I'll make a note here. Next 18. I'll forget. Next question 18. Okay. We will meet in the next class. Thank you. Correctly solve the question and get the answer.